All right, looking at some transformations today, very much an introduction, a lot of vocabulary. So if you're someone who struggles to care about vocabulary in math, it's going to be a tough day. All right, a change in position, shape, or size of a figure is called a transformation. Translations, reflections, and rotations, those are the specific transformations we're talking about. In this lesson, these are special. Okay, translations just moving it around, reflection is just flipping it back and forth, a rotation is just turning it. All of these are what we consider isometries. An isometry is a transformation that does not change the size or shape of a figure. Now that is really important. Isometry preserves congruence. Okay, isometry preserves congruence. We're also going to call those rigid transformations. We're performing a transformation that preserves congruence. Now, when we perform a transformation, the original figure is the pre-image and the result is the image. That should make sense. The pre-image has to come before the image. So the original figure is our pre-image. Now, when we are performing transformations and we have our pre-image and we have our image, we label these appropriately. And what I mean by that is we use letters, of course, to name the vertices, but the original vertices, the ones of our pre-image, would look normal. The new vertices are labeled with apostrophes, and we call these primes. So we know the image, which has been affected by some transformation, is J prime, K prime, L prime, M prime. We have performed that transformation to get that point. The prime is the new point. Now, once again, an isometry is a congruence transformation or a rigid transformation. We're going to hear those words a lot. Those words are pretty important. So a translation is a slide. We're just sliding it around. A reflection is a flip. And we can see some examples of these over here. And finally, a rotation is a turn. We know what a rotation is. All right, so we're identifying the type of transformation. We can see this first one right here is a reflection. It's been reflected. We can see the pre-image and we can see the image. It's been reflected to get the image. Here, this is rotating about point R. That is a rotation. It is rotating about point R. And finally, from this figure to this figure right here, it has translated. It is a translation because it is slide. And notice here, this is a good time to recognize this. The distance from M to M prime, N to N prime, P to P prime. Notice those segments that are connecting. Those are all the same length segments, and they're all parallel to each other, meaning they're all going in the same direction. So when we're performing a translation, every vertex is going in the same direction for the same distance. So we want to perform some transformations. For this first one, I'm going to move the camera. That's right. We're going on a field trip camera. Don't get too seasick. All right. So here's the figure, the same figure that was on the board over there. And we want to perform this rotation. I know I've already done the transformation, but let's just play dumb for a second. Act like we don't see this green figure, this green quadrilateral. We want to perform the rotation about that right there. So one thing that we can use is the idea that a rotation is an isometry. It is preserving congruence. So you could take that original figure, just like I did here, and you could essentially trace it. Now, what I did is I took this piece of paper, and I just plotted a point where each of these vertices are. Okay, so I have J marked down here, but I know there's L. That's actually my center of rotation. That's my point of rotation. And so I apply them because I know it's going to preserve congruence. I could essentially trace this out. I just saved myself some time by not tracing it all out. I just plotted points. But I know that whenever I rotate it and I have my final quadrilateral, it's going to be congruent to my original one. So I've got this, and I know I want to rotate it about point L. So I would rotate, rotate, and rotate until that segment between L and J lines up with the end of that arrow, because I want to rotate it until it stops right there. So that's what I do. And then I plotted these points actually on the whiteboard, and that's where we got this figure right here. So you could do that a lot easier on your paper, of course, but remember, use the idea that these transformations are rigid. They are congruence. The new image is always going to be congruent to the pre-image. All right, coming back. Yeah. Oh, all right. There we go. We made it. Now, continuing with these, B, we want to translate this figure. If we want to perform a translation, we want to slide it. And they gave us this segment right here, which has a direction, it has a length, and we want all of these segments to have that same direction and length. So I'm going to plot a few points that will help me with this. I'm going to measure it. Something like that. It's a giant TV, so I'm doing my best here. And so here are those segments. They should all be parallel. They should all be the same length. And if I connect them, it should be that figure, that P, shifted in that same direction. Finally, we want to reflect a figure across FG. There's the line FG. And the idea with a reflection is we find the distance from a point like D to the line of reflection, the perpendicular distance to the line of reflection, and then we find that same distance away from the line of reflection. So if this was 3 inches to be perpendicular to the line of reflection, we're going to go 3 inches away. And so again, we see our line of reflection. D needs to be the same distance away. E needs to be the same distance away. H needs to be the same distance away. We can connect these points to get our translated figure. Now, one really important thing to note is that F and F prime don't actually move. They don't change because F was on the line of reflection. How far did F have to go to get to the line of reflection? No, nowhere. It had to move, did not have to move at all. So that means it doesn't move at all to go away from the line of reflection. G and G prime are the same, but H prime, we can see it has been reflected, same distance away from that line of reflection. D, same way. E, the same way. Those points on the line of reflection don't actually move.